what you do is this. Okay, remember you have one folder for that one case study. So for another run, I recommend you to create another folder. Let's say we call it AERSCREEN. Now land cover, LC. Create another folder. And then you copy AERSCREEN, AirMod, MakeMat into that folder. Where is that? Inside this normal AERSCREEN, there's this AERSCREEN, MakeMat, and AirMod, right? You copy this. Don't delete it, don't cut it. Copy it and put it inside this new folder. So you have a fresh folder for another case study. So here I need to explain a bit about land cover and how it works. How do we account for the land characteristics, the surface characteristics in this AERSCREEN model or in the AirMod model? So how they characterize a surface is through this pie chart or through this diagram. Imagine the source is right in the middle, and then we separate the characteristics of the surface with sectors. So source in the middle. So this blue color sector has a certain type of surface characteristic. And then this is another surface characteristic and so on. So we need to specify the surface characteristics of each one. Now here I put in the maximum number of sectors, 16. But if, let's say, the area is mostly, for example, if this is vegetation and this is urban, then you only have 2 sectors. One for urban and one for vegetation. Or for example, maybe here is water surfaces, while here is urban surfaces. Is an urban surface and this is a water surface. So you just need to specify this and this. Notice in the simple 1 point, you just put in albedo, surface roughness, and bone ratio, right? Which means you are estimating that the characteristic of the surface around the source to be one color. I mean, just imagine this is one circle, source in the middle, and it's all one color or one type of surface. But using this way, when you spread it up, and then you can say that, okay, from this area, this region is a different surface, this region is a different surface. So, for us to give this information, we have to create a text file, another extra file, an input file, to give these details. Can you follow so far? Follow the logic? So, we create an out file in Notepad, but don't do it yet. It's a very specific format file. Means that you have to follow the format, the standard of writing the data. You cannot just list it out. You must be strict on the position of the data that you, or the information that you put into this file. This one I mentioned just now. Okay, minimum number of sector is 1. If 1 means the entire thing is one sector, one circle. The maximum number of sector is 12. I'm not sure, is this 12? 1, 2, 3, 4, 5, 6. Say 12. Each sector is 30 degrees. Yeah, 30 degrees, right? For each one. And each sector would have different albedo, bound ratio, and surface roughness values. Can you follow so far? So here would have a specific albedo, bone ratio, surface roughness. This one will have another albedo, bone ratio, surface roughness, and so on. So this is what it looks like, that file. This is the file that you need to create using Notepad. The first 4 rows consists of these lines. There's a frequency, FREQ underscore sector. This one has to be capitalized. You have to spell it this way. And then there's 2 spaces, so something like that. It has to be 2 spaces or 1 space. If it's 1 space, I'm not sure yet. I need to go back and confirm. But it has to be 2 space or 1 space. You cannot have like 3 space, 4 space. And this is what makes it a bit difficult, because you have to be very particular on the format. Then seasonal, then tree. Okay, this means that we consider 3 seasons. if there is 3 seasons. But in Malaysia, usually we can just consider 1. We don't have to worry so much about wet season and dry season. And all. The ones that are, when they mention, is like when it snows. Right? So we don't have snow here, right? So mostly we have, the surface is about the same type characteristic. So what's the difference? Why is it like if it snows, it's different? Because suddenly it's covered by white substance. White substance. And when it's white, what is the albedo of that? Yeah, total reflection. So that is, I mean, compared to ours, we say that we have dry season, wet season, monsoon and so on, but it's just whether it's wet or dry, right? But the surface is still about the same. So that's why we can just guess, we can estimate it to be 1 season. You don't have to worry so much about it. It's not going to change that much too. Say in Malaysia it's just 1 season, but if it's 4 season or 3 season and so on, this is what it means. And then this is where you specify the number of sectors. Okay, here means there's 3 sectors, means 3 angles. Sector 1, 100 to 215 degrees. Sector 2, 215 to 340 degrees. Sector 3, 340 to 100 degrees. So it's circular, it goes back. And then here, there's a keyword, you have to type it as so. When there's a star here, it means that the AERSCREEN will ignore this line. Anything that's not a star, AERSCREEN will take it as an input. Like for example, it needs to use this as an input, tree is an input, sector is an input. Here, star, season and so on, it's not an input for the model, it's just for us, for humans to read. We see that, okay, this season is for this, sector is this, and so on. But if it has a star means ignore. AERSCREEN will ignore it. So site characteristics, season number 1. Notice season 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. So this is for the year, right? 1, 2, 3, 4, 5, 6. Okay, 3 times 4, so 12. 12 months. 12 months in a year. Okay? So 12 months, sector 1, albedo 0.14, bone ratio 0.63, Z0 0.372. Then sector 2 is this, sector 3 is this. This is for season number 1, season number 2, season number 3, and season number 4. So, usually, from my experience, we don't really have to worry about this in Malaysia because it's going to be 1 season. So in the end, we can just use that input that we did just now, and that will be for the whole year. But like I say, if you want to practice on this, you can just use 2 season and then just see, just change it. Change this one to 2 season or 3 sectors and so on. See whether you have that. Okay, let's read through this. ANMAT seasonal tables. You would use seasonal tables if albedo, bone ratio, and roughness length change between seasons. In Malaysia, there will be negligible change in albedo, bone ratio, and roughness length values between seasons. The only change that might occur is bone ratio, if there is any. Depending on the season. Like if it's a wet season, then the bone ratio will be, I think, lower because there's more moisture in the air. If it's a dry season, the bone ratio will be higher. If the surface is wet for long periods such as rainy season or flood events, that's the only thing that changes. Albedo will probably be the same. Surface roughness also will be the same. If you want to consider this. So how do we calculate albedo, bone ratio, and surface roughness for different sectors? Now, the surface is not so simple as this. You know, you might say that, okay, we have, I think you've seen maps before, and then it's very heterogeneous. There's a lot of patches of, it's not going to be all with just one type of surface, right? Maybe here we have a different albedo, slightly different between here, inside here. So how do we find the mean for this particular particular sector? So we do that by using this way. If there is multiple albedo values inside a sector, we can just average it. That means if you want to really go into detail of this, you look at one sector and you look at the different type of surface and you specify a number for each type of surface. Like say one sector 0.4 and then 0.3, 0.2, 0.1 and so on. And you have all these values, you just average it. And that albedo value is the average for that sector. even though it has all these different types of values. That's what it means by arithmetic mean, standard averaging. Just average it. If it's Bowen ratio, we use geometric mean. Geometric mean is, multiply each value and root to the power of number of value. So value and root. I think I will show this later. Remember how do we calculate geometric mean? Let me check. Later, I'll explain this one later because we're not going to use it anyway. But anyway, if you have multiple Bowen ratio, if you want to get the representative Bowen ratio value for that, you have to use geometric mean. You cannot use standard mean. Because the value changed by quite a lot. It's like maybe one is 1, the other one is 0.1, then something is 10, and then it's 0.3, then 9. Notice the range is very large. If you average it, notice the value is going to be mostly high because you have 110 value. Notice if you average it, because you have some very small value, some very large value. So how do you get that in the middle of this very large range of values? You use geometric mean. It's another type of mean. Surface roughness is weighted by distance, geometric mean from the source up to 1 kilometer. So we consider surface roughness from this point here only up to 1 kilometer. We don't have to worry about so much at the far end. So this is an example. So sector 1 here, sector 2 here. So there's a water body there. Urban area. So this one, the entirety is just albedo 0.1, Bowen ratio 0.1, subtolerance 0.7. Notice the high surface roughness value, 0.7, because it's an urban area. There's a lot of obstacles in this area. And then sector 2 here, albedo is 0.1 also. I think average. Did I change it? Let me check. Okay, so here, actually, it's a bit different. Albedo, just now I mentioned, you have to, let's say you have a certain value. So you have to average the albedo, let's say between this and this. You get the albedo for this, you get the albedo for this, and you average it to represent this area. And the Bowen ratio is a geometric mean. If you have a Bowen ratio of this one and this one, you add them up using geometric mean. Surface roughness is the same. That's why I put 1 kilometer. Remember? So if 1 kilometer, this is 0.7. And then up to here is 0.7. So we don't consider this because surface roughness of the urban area is 0.7, high. But over the water it's low. But then we only consider the up to 1 kilometer. So here is up to 1 kilometer, so we still use surface roughness 0.7, even though there's a water body here. Okay? But let's say if this is up to here, then use geometric mean. Let's say water is up to here. Okay, maybe here 1 kilometer from here to here. Then you have the surface roughness here, surface roughness here. To combine them is geometric mean. So I think you can try this. You have to create this file. Okay, before that, so the assignment, the thing for you to do right now is to create this file, and I'll tell you how to do that later. So other resources concerning land cover is use Google to get the albedo and so on. Determine the surface type you're interested in modeling over. You can use Google Earth to do that, or Google Map, just to look at the area. Search for significant publication and look at the table figure for this. Oh, this one if you want to calculate the albedo, to retrieve the albedo Bowen ratio values. Remember I showed this one before. Remember this one, these slides? Some of these slides, these values. You can use this if you want. For albedo, for Bowen ratio, for surface roughness. can use this for a first estimate if you don't want to search Google for it. And then, okay. Yeah, either use Google to get it, or you can use this user guide for AMS EPA. A PDF, you just Google it, then you can download the PDF for the table of values. Okay, before we can run for this one, you have to create this file. I'll show you how you do that. Right, so this one you have to be very specific and very careful about the spacing. So we want to recreate this. You don't have this file yet. You only have a picture of it, right? You want to create the text file. What do? You first open and choose Notepad. And you input this data like this. First line, you need to have you need to go 4 spaces to the right using a space bar. So 1, 2, 3, 4. And then you start. Sorry, 3 space bars. So going back, 1, 2, 3. And then type in the keyword frequency underscore sec. And then, let me double check. 1, 2 spaces. 1, 2. Don't use Word for this. You have to use Notepad, okay? You have to use Notepad. And then type annual, capitalize. And then again, 2 space, I think. 1, 2, and then 2. That means 2 seasons. Then go to the next line by pressing enter. Then again, 3 space. Type in sector. And then 2 space, 1. Four spaces actually. 4. So 1, 2, 3, 4. Then 1 for sector number 1. 1, 2, 3, 4. 1. Oh, here's 7 space. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 0.10. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5.
2 lines.
Huh?
2 lines.
2 lines?
Sectors, the ones that...
Oh, yeah. I jumped it. Sorry. Sector 1. Maybe I think I can write down like this. Oh yeah, 3. Okay, and then 2, and then 2. Itu, okay? And then 3, and then 2, 1, and then wait. Factor to 1 is 3.
And then 4.
1, 4.
0, 100.
Okay.
Now one circle again.
Let me try this. I'll add this one first. Yeah. Semua. All. Yes. Yes.
No, that was a site. Site.
Oh. Which one? This one? It should be 2. Looks the same, doesn't it? 2. Okay. 4 and 7. Two, 7, 4. Okay, so here, okay, now notice one thing, this part here, I know it says from 1 to 0 is 4, right? But then over here, below, it has, the 0 and 0 has to align. And then there's 2 extra numbers in front, so actually it's actually 2. If it's less than 3 digit, then you have to go up to 4 up to this point. But if it's 3 digit, then you have to go in 2. Notice that the line, the right digit aligns. Okay. So create this file. Make sure you save it as a .txt file. You just do this first, and then we'll save it together. Okay. It might be difficult now, but once you create this land cover text file, you can reuse it. You already have the spacing, right? So if you want to change it for other surfaces, then you just use that spacing. You just have to create it once. You don't have to create from scratch every time.